In this video, we're gonna discuss the new topic on the techniques of integration. The techniques of integration, the name say that we're gonna integrate for sure. However, we learned one technique before. It's gonna call the integral by the substitution rule. Okay, so we're gonna have the first one that quite important. It's called the substitution rule. So we learned this one before, okay? And we're gonna study other techniques in this chapter. And other techniques that we're gonna study turn out to be four important ones, which are integration by part, trigonometric integral, the trigonometric substitution, and the rational function and partial fraction. We're gonna study them. So first one, integration by part. The second one is gonna be the trig integral. We're gonna study this guy together with the trigonometric substitution. And the partial fraction, we're gonna have two applications. Okay, so for this partial fraction, it's gonna turn out to be two applications. It's gonna be the integral of rational function in sine, cosine, and the rational substitution of the n root of ax plus b. So like you're gonna have by part, you're gonna have trig integral, and you're gonna have partial fraction. Okay, so this is gonna be the conclusion, what we gonna see. And this guy is called the techniques of integration. So we have substitution before, now it's gonna be other techniques. So this chapter involving a lot of algebra. So let me mention this guy first. So it's gonna be involving a lot of algebra. So let's begin with the first one, which is called the integration by part. The integration by part comes from the product rule. You have the duv, which is the product of two functions. It's gonna give you udv plus vdu, the first derivative of the second plus the second derivative of the first. So this one is the product rule. If you integrate both sides, you see that it's going to turn out to be integral duv equal to integral udv plus integral v du. And integral duv is going to turn out to be just uv because integral and the differential cancel each other. So you get uv equal to integral of u dv plus integral v du. And you see that this is integral of u dv and integral of v du. So integral of u dv, this guy, turned out to be, okay, integral of u dv, turned out to be uv subtract by integrate of v du. So this is the way to write it down. However, you may ask me that why do we need something like this? It looks like changing or interchanging the variable kind of, right? So you see that when we like to integrate something like this, okay, when we like to integrate something like this, it's kind of difficult to integrate because this is a product between two functions and we don't know how to integrate it yet. So we're gonna try to change this guy in terms of udv. So what does it mean to change this guy in terms of udv? It means that you're gonna just see one term to be u and the other term to be dv. And we learn this one that this guy is u, this guy is dv. So this one, you see that it's gonna turn out to be what? It's turned out to be, how would I have this guy in dv? So it's dv equal to e to the x dx. And you may ask me, hey, what is I write dE to the x? Okay, so dE to the x. So you dip e to the x, it's gonna be e to the x, right? So for this one, you may write this one as x d e to the x like this. Okay, so this is how we see the bypass thing. And you see that it's gonna turn out to be u dv. Let me use other color instead. So it's gonna be de to dx. Okay, so you see that it's gonna be turn out to be u dv. And the problem that you see is gonna be this one, if you use the by part, it's gonna turn out to be uv. So you have uv. Okay, so you see it's gonna be easier to see, it's gonna be uv. So this one is x e to the x, and you have minus integrate of v, which is e to the x, and du, which is dx. So the thing that I like to emphasize will be, you see, it's gonna be just u in this case turn out to be x, and v in this case turn out to be e to dx. Okay, so you have u and v, and you see that it's kind of make like you see that you be able to change from the difficult integral. So this one is kind of complicated to something easier to integrate, okay, by using the by-part formula. What is the by-part formula? Let me recall this guy up here. So you have integral u dv equal to uv minus integral v du, okay? So this one involving the technique of differential, okay? It's kind of difficult to see, I know, but I'm gonna teach you step by step later. However, I like to point out that you'll be able to change from the complicated one into the easier one by using the thing that called the integration by part. Okay, and we're gonna do that like we're gonna be able to just have the final answer. So for this one, you see that after you change into integrate of e to the x dx, so this guy turned out to be just e to the x plus c, and you have your final answer. Okay, so this one you just conclude that integrate x e to the x dx is gonna turn out to be x e to the x minus e to the x plus c. So you can just have this integral in terms of like it's not substitution, it's going to be by part. By part is going to be the formula that change your complicated integral into the easier one that you can manage. Okay, so that I'm gonna write it down here. So you see I'm gonna mention that this guy is the complicated one, and you're gonna get the easier one. Okay, so you use the by part to do this job for you. Okay, so and when you do by part, sometime you're gonna have to deal with integration of e to the ax, integral of sine ax, and integral of cosine ax throughout this chapter. So you may just use the substitution. So you may just use the substitution to let u to be ax. Okay, so in this one, you're gonna get u to be ax. Okay, and you just use the substitution. So you get du equal to a dx. So you'll be able to have dx equal to du over a, and you'll be able to obtain this three formula. So how could we use this one? We'd be able to use this one in terms of if we want to integrate like a e to the 2x dx. So this guy will be just e to the 2x over 2 plus c. Okay, so you just identify your a. So you have a equal to 2, and you just plug into the formula. For the second one, if you want to integrate cos x over 3 dx, So you integrate cos x over 3 dx. In this case, you have a equal to 1/3. Okay, so you have a equal to 1/3. So you integrate cos, you get sine x over 3, and it's going to be over a. So it's going to be over 1/3. Okay, and you plus c. Okay, so C, not C, A can be fraction, A can be whole number, A can be like a irrational, like A can be root 2 or pi. So for example, if you want to integrate, let's do number 3, integrate sine pi x dx, okay? So when you like to integrate sine pi x dx, you're gonna use a equal to pi and you plug into the second formula here. So you would get cos pi x over pi and plus c. Okay, so this is how we integrate e to the 2x cos x over 3 sine pi x. You can use substitution, but it's going to take longer. We're going to just use formula for this one. The next one will be if you identify dv in terms of something dx. Okay, so if you have dv in terms of something dx like this, how could we find v? So let me discuss this one. For using the by part, so you have you compute du, so you dip, okay, so you get du. However, in this case, you know dv. In order to get v back, so you're gonna have v equal to integrate dv. So this one you're gonna integrate instead, okay? For example, you like to find v for dv equal to 1 over x dx. So you're gonna just have v equal to integrate 1 over x dx. And integrate 1 over x is gonna be log absolute x plus c. Okay, so this is my v. The second one, dv equal to 1 over root x dx. So you get 1 over root x dx. And you integrate 1 over root x, so you get 2 root x plus c. And the next one, you get v equal to integrate cos x dx. Okay, so you integrate cos x dx. So in this case, you have integrate cos, you get sine x plus c. Okay, so you get cos, you get sine x plus c. And the next one, you have dv equal to sine 2x dx. So it's going to be v equal to integrate sine 2x dx. And this guy, you get negative cos 2x over 2 and plus c. And for the next one, you have dv equal to secant square x dx. So you integrate secant square 2x dx. So it's going to be tan x plus c. And finally, you have v equal to integral of e to the 2x dx. And you get tan x. So it's going to be not tan x, so it's going to be e to the 2x over 2 plus c. Okay, so this is how we have this integral. Okay, so with me so far on this one, so you'll be able to find v, and for computing du, it's going to be just you're going to differentiate the function. The next one, we like to integrate xe to the x dx. Like I told you here, you have to be able to find v from obtain dv like this one. So the thing is you have u equal to x, you have dv equal to e to the x dx, okay? And you have how to find v. How to find v is if you don't know, okay, so in the case that, hey, if I don't know, I know just dv equal to e to the x dx, how would we find v? So in this case, it's going to be integrate e to the x dx, and it's going to be just e to the x, okay? So it's going to be just e to the x plus c. And this is how you know, okay? So you just have e to be equal to e to the x plus c. This is how we know this one, okay? And you may ask me that, so when we integrate x e to the x dx, would that be integrate x and you find dv, so it's going to be de to the x plus c, okay? So it's going to be de to x plus c. It would actually, so in this case, you get x that I'm going to highlight, the yellow one, and you have e to the x dx that I will underline. So it's going to be this guy and equal to this guy, right? So you're gonna use by part. Okay, so you're gonna use by part. So it's gonna be uv. So it's gonna be e to the x plus c minus integrate e to the x plus c and du, which is d, the yellow guy. And you see that this one turned out to be x, okay, e to the x plus c. So it's going to be x plus c, not x plus c, x times c, minus integrate e to the x is going to be e to the x, and integrate c, you get what? Integrate c, you would get, let me put parentheses, so it's going to be cx or xc. Okay, so in order to like ease my calculation a little bit, let me change c to c1. Okay, so let me just use c1 here to have the difference c. So I get 1, 1, 1, 1, 1 like this, so that my c1, okay, so it's going to be my c1, and you can plus the same c here, so you're going to plus c. Okay, so you're going to plus c. So you'll be able to get rid of these two guys because they have opposite side, and you see that the final answer turned out to be x e to the x, okay, minus e to the x plus c. So what do we learn here? We learn here that we do not need, okay, so we do not need to plus c1 when we find v, okay, because the integration by part will cancel c1 anyway, because the formula will cancel c1 at the end. Okay, so you don't need to plus c1 yet. However, for the last c, you need to plus c. We need to plus c for final answer. Okay, so this is the thing that I would want to notice first in order to, before I move on this one. Okay, and this one, the thing that I like to explain will be, if you want to know, okay, so if you want to integrate 0 to 1 x e to the x dx. Okay, so if I ask you to integrate 0 to 1, how would we have? We have the antiderivative. Okay, so the antiderivative is this guy. Okay, so this one is your antiderivative. Okay, so this one is antiderivative. So you're gonna just have the antiderivative copy down. Okay, and this one is the antiderivative that you copy it down here. Okay, and you're gonna plug in x equal to 0, x equal to 1. The thing that I like to point out will be when you plug in x equal to 0 and x equal to 1, don't forget to plug in both terms. Okay, some of you just plug in the second term and leave the first term for me to plug in by myself, or you have the final answer in terms of x. It's not happen that way because you are computing the the definite integral in this case. It's gonna turn out to be number for final answer. So you're gonna get this guy, so it's gonna be e to the first. Let me use this space. So it's gonna be e to the first times 1. So it's going to be 1 e to the first minus e to the first minus 0 e to the 0 minus e to the 0. Okay, and e minus e equal to 0 for this term, and this guy equal to 0. Okay, so you have e to the 0 finally equal to 1. So this guy will be just equal to number 1. Okay, so that's my final answer. So the thing that I ask you to do by part will be when you like to integral for the definite integral like this one that you have the boundary, the upper and the lower limit that you have to subtract them. You're gonna integrate first. After you integrate, you're gonna get the antiderivative. Okay, so you have gonna be, it's gonna be more than 2 terms for sure. So it's gonna be 2 terms. It's more than 1 term for sure. So you're gonna integrate first, and then you plug in both of them in order to obtain the final answer. The last thing that I like to mention will be, how would I know that for the final remark here, how would I know that which one gonna be u, which one gonna be dv? Okay, so which one gonna be u, which one gonna be dv? We have several things. So in this case, the first thing that I like to remark will be when you see x e to the x dx, you have several decisions in this case. You can let u to be x, okay, and dv to be e to the x dx. So you can have u to equal to x, dv equal to e to the x dx. Or you can have u equal to e to the x, and you have dv equal to x dx. And also, you can have u equal to x e to the x and dv equal to dx. So we have several guys that you see here. How would we know that it's going to be which one to the one that is going to be working? So let's try. So you have the third one. Okay, so for the third one, you have u equal to x e to the x. So in this case, you're gonna compute du. Compute du, you see that this guy is gonna be product. So in order to compute du, you need to use product rule. So it's gonna be the first derivative of the second plus the second derivative of the first. So it's gonna look like this, and you have dx. So this one, you see that du turned out to be more complicated term than the previous term that we have. So we have only one term for u, one term for dv, and when you compute du, it turns out to be big and we not be able to control it. So it's going to be more complicated. Okay, so this one is not working. Okay, so it's going to be no, because it's going to be more make your life more complicated. The next one, you see u equal to e to the x and dv equal to x dx. So if in this case you compute for v, you're gonna integrate x dx. And if you integrate x dx, you would get x squared over 2. Okay, and you see that this one has exponent equal to 1, and this guy gives you a bigger exponent. Okay, so you see that this one is exponent 1, this one is exponent 2. So the exponent seem bigger exponent. Okay, so you get a larger or bigger. Let's use larger. So it's larger exponent. Okay, so you use the second case and you obtain a larger exponent. So it's going to be more complicated. Okay, so this one also not working. So not working. And it's going to be no again. Okay, so you see the thing that I try to explain will be sometimes we have several. Normally it's going to be most of the time. So most of the time we're going to have several cases for u and for v. Okay, however, the thing that we're going to make to decide, we're going to use to make a decision, in this case turn out to be, you just try. Okay, and you see that if it's going to make your life more difficult, you're not going to use that. Okay, so that's going to be the trick that I ask you to recognize. Okay, so x e to the x, you're going to have u equal to x dv equal to e to the x dx. Can we do with other? Okay, so can we do this trick with other? Let's try. For number 2, you have x psi x. Let's do x psi x. For x psi x, you see that you have several things. You can have u to be x, dv to be e to the x. Okay, so let's write them down. First, you have how many cases? You have 3 cases, the same thing. So you have u equal to x. Okay, you have u equal to x and dv equal to psi x dx. You can have u equal to psi x and dv equal to what? dv equal to dx, x dx. Okay, so in this case, we will be x squared over 2. Okay, so in this case, it's more complicated. Okay, so we not gonna use this guy. Okay, so it's not gonna be using this guy. And last one, you have u equal to x psi x and dv equal to dx. So in this case, you're gonna see that you're gonna have du product. Okay, so it's gonna be product rule. Okay, so this one also more complicated. Okay, so the thing that we're going to use in second case here is going to be the first one. Okay, so you're going to have u equal to x and dv equal to psi x dx. Okay, similarly, this guy can be applied the same trick for x. So this one, let me erase this one. I forgot the x. So it's going to be x psi x dx. Okay, or you have x cos x dx. Okay, so you have x psi x dx and x cos x dx. So this one is no, this one is no, and this one is okay, right? Another one you're gonna have, okay, so that one is gonna be, I'm gonna remark this one first and I'm gonna teach you example 2. For example 2, it seems, hey, how would we know that it's gonna be by part? Indicate sine root x dx. If I were you, I'm gonna use substitution. You may say that, right? So I'm gonna use substitution. I'm gonna let u to be root x, and I'm gonna compute du, okay, 1 over 2 root x dx. Okay, it's not that hard to understand this one, and you're gonna see that your dx turn out to be 2 root x du, and you see you here that u equal to root x. Okay, so you have u equal to root x, so this guy will be 2u du. Okay, so this is the thing that you may feel first. And then you're gonna substitute. So this one is the trick that we have learned before. So it's gonna be psi, okay, u, and dx is gonna be 2u du. Okay, so this is it. Yeah, so you have u here. Okay. And so the thing that you get turned out to be product. So it's going to be integral of 2 outside. Okay, so it's going to be 2 outside, and you integrate of u psi u du. And you see that, hey, this one is the thing that I just mentioned. It's x psi x. Okay, so in this case. So you see that it's going to be kind of confusing to use u, right? Because in by part, we're going to use u and v again. So normally when we study the the integral here, we're going to change u to w in order to ease the notation. Okay, so we're going to ease the notation a little bit by changing to w. Okay, so this one, let me just use w, okay, psi w. Okay, so it's going to be easier to read, okay, when we use by part. Okay, so you have w equal to root x, you have dw equal to 1 over 2 root x, and we're going to have everything in terms of w right now. And we're going to use by part for this term. And the question may rise that, how would we know it's going to be by part? Because we already used substitution, right? And this one turned out to give you what? Turned out to give you product. Okay, so you see w times psi w. So this one turned out to be in terms of product that you're gonna see that we cannot do anything much except we have to change into easier term for VDU. Okay, use by part, and we hope VDU will be easier. Okay, so this is the thing that you have to keep in mind. I'm gonna write this one step by step. Okay, so I'm gonna just use by part for this one. So I'm gonna let u to be w, and you have dv equal to psi w dw. Okay, so you have dv equal to psi w dw. So you get du equal to dw, and you have v equal to integrate psi w dw. Integrate psi, you get negative cos w. Okay, we're not plus C1 yet, like I told you. So this one, when you use by part, you see that dv equal to this and v equal to this. So you use by part, it's gonna turn out to be, okay, so this term, let me write this one down. So it's going to be 2 and it's going to be uv. So it's going to be w times negative cos w minus integrate negative cos w, and dv is du is going to be dw. So this one will be uv minus integrate v du. Okay, and so you're gonna get 2 and you have negative w cos w, and you see that this one turned out to be plus integrate cos w dw, and you see that this one, as we hope, this guy turned out to be easier. Okay, and we be able to just compute this guy. So it's gonna be just 2 negative w cos w, and you integrate cos, you would get psi w plus c. Okay, so this is how we obtain the final answer. Okay, and don't forget that we begin with everything in terms of x, so final answer, you're gonna write this one, it's gonna be negative root x cos root x, okay, plus psi square root x plus c. Okay, so this is your final answer. Okay, so I hope this one is correct. Okay, so for this one to here, so you put w equal to square root x back. Yeah. Okay, so this is how we obtain the final line or the final answer. Okay, so this is the whole question. For the whole question here, you see that we begin with the substitution. So the first 3 lines or maybe 4 lines here, it's going to be just the substitution. Okay, so you use a substitution and then you be able to obtain this guy and you be able to obtain the final answer. Okay, substitution for the first step, and then you use by part. Okay, and don't forget to put back w equal to root x. The next one is gonna look like the previous one, but now it's gonna be x cos 2x. Okay, so in this case, you're gonna just use by part. Okay, so you're gonna let u to be x and dv to be cos 2x dx. Okay, so you have u equal to x, dv equal to cos 2x dx by the remark that we have mentioned before. And so you're gonna have du equal to dx, and you have v equal to integrate cos 2x dx, and integrate cos, you would get psi 2x over 2. Okay, don't forget over 2. And then what? And then you're gonna just change this one. Okay, so before I have plug in this guy and this guy, let's just integrate first to find the antiderivative. So we're gonna just say find antiderivative first. Okay, so we're gonna find an antiderivative. So you're gonna just have x cos 2x dx. Okay, So this one is going to be u together with dv. Okay, so it's become uv. Okay, so I'm gonna just use my yellow color uv. Okay, so uv. So you have uv, which is x psi 2x over 2 minus integrate v, which is psi 2x over 2, and du must be dx. Okay, and then you see that this one is going to be easier. Okay, so we have turned from more complicated into easier. So you would get x psi 2x over 2, and you integrate psi 2x, so this one is going to be 1/2. Okay, and integrate psi 2x, you're going to get cos 2x, okay, over 2. Don't forget the negative side. Okay, so you get integrate psi 2x dx here. Okay, so this one that I mentioned, it is easier. So this guy is going to be this one. Okay, and you get integrate cos 2x, so it's going to be pi over 12 to pi quarter x cos 2x dx. Okay, so it's going to be just x psi 2x over 2 minus become plus, so it's going to be plus cos 2x over 2 times 2 is 4. Okay, so it's going to be from what is called pi 12, okay, to pi quarter. Okay, and then you're gonna just plug in x equal to pi quarter, so it's gonna be pi quarter. Okay, uh, multiply by 1/2 and psi 2 pi quarter, so it's gonna be pi over 2. Okay, plus cos pi over 2. Okay, so that my one term, the first term. The second term turned out to be pi 12, 1/2 psi pi over 6 plus 1/4 cos pi 6. Okay, let's evaluate for value. Psi pi over 2 equal to 1, cos pi over 2 disappear to be 0. Okay, so this one turned out to be equal to pi over 8. Okay, and you have the second term turned out to be disappear, and you subtract psi pi over 6 is 30 degrees, so it's going to be 1/2. So it's going to be minus pi over 12 times 4 is 48. Okay, and you get minus 1/4, and cos pi over 6 is equal to square root 3 over 2. Okay, so this one is 1/2. So you get 1 over 2, and it's going to be root 3 over 2. So this is how you obtain. You may evaluate or you may combine the term, but you may not have to. Okay, let's combine. It's 5 pi over 48 minus square root 3 over 8. Okay, so that would give me the final answer for integrate of x cos 2x from pi 12 to pi quarter. Okay, so here the first one is going to be finding antiderivative, and the second step begin here. Okay, so the second step, you just plug in for value. Okay, so this is, you gonna get the final answer in terms of number. The next two together is going to be the important one. You would want to integrate x log x dx, and you would want to integrate 1 to e of x squared log x dx. So let me just not integrate x log x. So the intention that I like to do is going to be, I like to integrate just x, not x. I like to integrate just log x. Okay, so let me just integrate log x without x. Okay, so if I want to integrate integrate log x, we don't know how to integrate log x. So let me just first recall you that we know how to dip. Okay, so we know how to differentiate. So we know how to diff the dx of log x is 1 over x. But we don't know integrate. So normally you're gonna memorize that integrate log x equal to 1 over x, which is incorrect. Okay, so integrate log x, memorize that, use by part. Okay, so you have to use by part. Okay, the thing that you should memorize will be, you integrate log x, you're gonna use by part, and you're gonna let u to be log x. Okay, how could I know that it's gonna be u equal to log x? You have only one choice. Okay, so u equal to log x in this case is gonna be only one choice, and you're gonna have dv to be dx. Okay. Okay, so you have dv to be dx. So you get du equal to 1 over x dx, and you have v equal to x. And then this one is very nice for doing by part. So this guy turned out to be uv, so it's gonna be log x, okay, multiply with x, okay, minus integrate, okay, so minus integrate v, which is x, okay, and du, which is 1 over x dx. Okay, so this is how we find this integral. And then what? And then you see this guy make the second guy easier because x can be cancelled with the x here. So this guy turned out to be integrate of 1 dx. And integrate 1 dx turned out to be x plus c. Okay, and you may just copy this guy down. Okay, so you're gonna copy, you paste. Okay, so you're gonna paste another guy here. Okay, so you paste these two down here like this. And this one turned out to be, you have integrate log x, so it's gonna be log x times x minus x plus c for final answer. So that is integrate of log x. Okay, so integrate log x is going to be x log x. Normally I'm gonna memorize. So if you want to memorize when you study other subject, so sometimes integrate log x will be useful to memorize. So you memorize this guy, obtain, it's not from the substitution, it's going to be obtained from by part, and it's going to be x log x minus x plus c. Okay, so that the integral of log x. You may memorize this one. Okay, so you may memorize this one. For the next one, okay, you're gonna integrate 1 to e of x squared log x. So in this case, let's first compute integrate x square log x dx. Okay, so we're gonna integrate x square log x dx. So again, we shall use by part. So you're gonna let u to be log x. Okay, so you let u to be log x, and you have dv to be x square dx. You may ask me, you have dv equal to v, dv equal to x square dx. Okay, you may ask me one thing that, hey, this one, you know, dv equal to x square dx, right? So when you solve for v, the power or the exponent turn out to be higher as before. So you see that it's going to be integrate of x square dx, and we cannot avoid, it's going to be x cubed, okay, over 3. So it's going to make the exponent larger like we had before, and we not be able to use it for integral of x e to the x, right? It's not in this case, because the thing that you see is going to be, you have the by part thing, and you have this guy x cubed over 3. You cannot have u to be other term. If you have u to be what? If you have u to be x squared, you not be able to solve for dv, because dv will be log x dx, and you not be able to integrate it yet without using by part again. So it's not fun to do that way. However, if you have u to be x log x, u to be x squared log x, du turn out to be too complicated. And you see that this one, the power is larger, but if you compute du, it's going to be 1 over x dx, okay? And you see that when we combine with du, it's going to turn out to be very nice, okay? So it's going to be, this one is x squared log x, right? So this one is turned out to be uv, so it's going to be log x, and v will be x cubed over 3 minus integrate v, which is x cubed over 3, and du will be 1 over x dx. And you see that this one, the power that seem larger turn out to be cancelled with 1 over x to get the power kind of the same thing, and without any other complicated term. So you see that this one turn out to be log x multiplied with x cubed over 3, and you integrate, so it's going to be 1/3 x squared dx. Okay, so you get rid of x cubed and x here, so you just have 1/3 x squared, and so you get log x cubed over 3, and you have 1/3, and you have integrate x squared, so it's going to be x cubed over 3, okay, and then you're going to plus c, okay. So this is how we obtain the antiderivative. So the next step, we're going to plug in. So the second step, so you have integral from 1 to e of x squared log x dx. So it's going to be just 1/3, okay? And you have log x x cubed minus x cubed over 9 from 1 to e. Okay, so like I mentioned earlier, so don't forget that you have to put e and put 1 for both terms here. So this guy will be, let me, so for this guy, let me enlarge this one, and I will have the space enough. So this one is going to be 1/3, and it's going to be log e multiplied with e to the third minus e to the third over 9. okay, minus 1/3 log 1, okay, time 1 cube minus 1 cube over 9, okay. So this one will be, okay, so log 1 is 0, so this term equal to 0, log e equal to 1, okay. So final answer will be 2, okay. So this one will be e cube, okay. So it's gonna be this one, so you plug in, okay. So it's going to be e cubed over 3 minus e cubed over 9. So it's going to be 2e cubed over 9, right? 2e to the third over 9, okay? And for the last term, it's going to be negative. Negative become positive. So it's going to be plus 1, 9. Okay, so it's going to be 2e cubed over 9 plus 1, 9. And this one will be your final answer. So for this slide, you get number 4 and number 5 that you are dealing with intricate involving the product of log. So let u to be log, okay? Keep that in mind. The next one will be you like to integrate the arc trigonometric function. Okay, so it's going to be arc trigonometric function. So it's going to be, you're going to let u to be that arc trigonometric function. So you have only one choice in this case. So you're going to let u to be arc psi equal to arc psi. Okay, so you get du equal to dip arc psi is 1 over 1 minus x squared dx inside square root, and you have v to be dv to be dx, so you get v equal to x. So for by part, it's gonna turn out to be uv, so it's gonna be x arc psi x. So it's gonna be arc psi x multiplied with x minus integrate v, which is x, and du, which is 1 over square root 1 minus x squared dx. So for this one, you're gonna get x times arc psi x. Okay, so in math, we're gonna do it that way. And you're gonna have to integrate x over square root 1 minus x squared dx. And for this one, you're gonna have to use substitution. Okay, so you would let w to be 1 minus x squared, and you have dw equal to negative 2x dx. Okay, so this one would give you negative 1/2 dw equal to x dx. Okay, so you're gonna change your x dx to negative 1/2 dw. Okay, so you're gonna just obtain negative 1 over root u and negative 1/2 du. Okay, so this one will be your u, not u, right? It's gonna be w, sorry. So it's gonna be w. So it's gonna be dw. Okay, and then you're gonna integrate this guy, so it's gonna become positive 1/2 2 root w plus c, okay, and 2 and 2 cancel each other, so it would give you finally square root and w equal to 1 minus x squared plus c. So this one is final answer. Okay, so it's going to be w equal to 1 minus x squared, and you'll be able to find this integral. Finally, let's copy down this term. So you get x arc sine x. Okay, so you can have x arc sine x plus square root 1 minus x squared plus c for the integral of arc sine. Okay, so again, dip arc sine equal to 1 over square root 1 minus x squared. However, integrate arc sine used by part. Okay, integrate arc sine used by part. We not memorize it. Okay, so we just say used by part. Another one, you have integrate x arc tan x. Okay, so you have integrate x arc tan x. So for this one, you're gonna just integrate by using by part for u equal to arctan x. How would I know that you're gonna be arctan x? Because like I told you before, you must be arctan x, but if you have u equal to x arctan x, it's gonna turn out to be using the product rule, and it's gonna make our life more difficult. Okay, so you're gonna just let u to be arctan x, and you're gonna have dv equal to x dx. Okay, so you're gonna get du equal to 1 over 1 plus x squared dx, and you have v equal to integrate dx, so it's gonna be x squared over 2. Okay, so I not use color anymore because this one is 7 example, so we kind of like know this one already. So you use by part. Okay, so you use by part. Okay, so you have integral of x arc tan x dx. Let me write this one in terms of u dv. So you get arc tan x times x dx. So this one is u, this one is dv. So you're gonna get uv, which is arc tan x multiply with v, which is x squared over 2, subtract by the integral of x squared over 2, which is v, and du is 1 over 1 plus x squared dx. Okay, so this one is uv, okay, and this guy is v, and the whole thing here is du. Okay, and then what? And then you see that this one is seem complicated, but it's not that a lot complicated as before. So this one is going to be just integrate, and you have x squared 1 plus x squared dx. Okay, so you're gonna do the trick that we have seen earlier. So you see that I'm gonna add 1, subtract 1. So I get 1/2 integrate, and you get x squared plus 1 over 1 plus x squared, and you subtract 1, okay, over 1 plus x squared dx. And this guy is equal to 1. Okay, so this guy is equal to 1. So you get 1/2, and you integrate 1, you get x. Okay, so you get x. Let me write in the green color. So you integrate 1, you get x, and you integrate 1 over 1 plus x squared, so you get arctan x. Okay, so this is how we have this integral, and you're gonna have to plus c, okay, for final answer. So this is the final answer for integrate x arc tan x. So it's gonna be arc tan x times x squared over 2, okay, minus 1/2 times x minus arc tan x plus c. Okay, so this is how we integrate. Okay, and here you just do the second step. Okay, so the second step is here, the integrate. So this one is going to be just not the substitution, it's going to be just the algebra that you simplify the term in order to obtain the final answer. So for this one, it's going to be integrate x arc 10x dx for final answer. Okay, so that will be okay. So for the next one, you have integral of x squared to the x dx. So before I go to this number 8, let me make remark for the thing that we have learned. Okay, so you have this one, and you have number 3. Remark number 3 will be when you have x to the k log x dx. Okay, you're gonna let u to be log x and dv to be just x to the k dx. So this one we have learned from the previous example. Okay, so you have u equal to log x, dv equal to x to the k dx. This one from page 8. Okay, so this one is from page 8. And for number 4, when you like to have arctric x, okay, arc sine, arc tan, okay, so when you like to integrate arctric x, okay, so you're gonna let u to be that arctric x, okay, and dv is the rest of the term. Okay, so dv turn out to be anything that you have left. So if it's gonna be x arc sec x, it's gonna be u equal to arc sec x, and dv will be x dx kind of. Okay, so that is going to be when you like to integrate arc trigonometry, you will be that arc trig x. So that is going to be, you have to keep this in mind in order to deal with this kind of stuff. Okay, so it's going to be 4 things that you need to memorize in your head right now. And the next one, you see that it's going to be fall into the first case. So you have e to the x before. Okay, so in the first case, you have e to the x before. Now you have 2 to the x. So you have 2 to the x. So in this case, it's going to be followed because they are exponential function. So it's going to be, you're going to let u to be, just e to the x. Okay, so you're going to just let u to be e to the x, and you'll be able to just have dv equal to x squared. Sorry, you're gonna let u to be x squared. Yeah, so you're gonna be u equal to x squared. So you're gonna let u to be x squared and dv equal to 2 to the x dx. So you get du equal to 2x dx, and you get v equal to integrate 2 to the x dx. So it's going to be 2 to the x over log 2. And so you shall use by part x squared 2 to the x dx. So for this guy, it's going to be uv. So it's going to be x squared times 2 to the x over log 2 minus integrate v, which is 2 to the x over log 2, and du is 2x dx. So you see that you use by part and you get something. However, for this guy, okay, so I'm gonna circle. For this term that you have here, you not be able to integrate this guy out yet. Because what? Because it's gonna turn out to be again 2 to the x, okay, 2 to the x times x, okay. So it's not good, it's still product. I'm gonna say that it's still product. And you not be able to integrate it yet, okay. So we may have to simplify this product a little bit. We not be able to cancel, we not able to get rid of. However, we be able to use by part for this circle, okay. So use by part again, use by part again, okay. So we use by part again for this term, okay. So we use by part again for this term. We're gonna again letting you to be we're gonna let you to be x, okay. So let u to be x and dv to be what? Dv to be 2 to the x dx. So you get du equal to dx and you get v to be just 2 to the x over log 2. Okay, so this one, you see that you'll be able to use by part again, and you allow to change this one. So you have two outside, and you're gonna just have uv. So it's gonna be uv. So it's gonna be x 2 to the x over log 2 minus integrate v, which is 2 to the x over log 2, and du turn out to be dx. Okay, so you see that after we use by part for the second time, you'll be able to obtain the one that kind of without any product. So it's going to be just any nice term. It turned out to be a nice term here, and you'll be able to obtain the final answer. So I'm going to say this is first by part. Okay, so first by part. Okay, and this guy is the second time by part. Okay, and then you're gonna copy other term down. So it's gonna be x squared 2 to the x over log 2. Okay, and for this one will be x squared 2 to the x over log 2, and you have 2x 2 to the x over log 2 plus, so you're gonna just integrate the yellow guy. So you see that it's gonna be 2 over log 2 first, and then you integrate 2 to the x, you get 2 to the x over log 2, and you're gonna plus c. Okay, so this one is the integral of the yellow guy multiplied with 2. Okay, and this will be your final answer. So I not need to simplify this one. Let's simplify this one a little bit. So you get x squared 2 to the x over log 2, and this one is 2x times 2 to the x over log 2 plus you have 2 over log 2 square times 2 to the x plus c. Okay, so this is how we obtain the final answer in this case. So what do we learn so far? We learn how to integrate the complicated function normally in terms of product, and we be able to get rid of the product by changing into the easier one using the integration by part formula. And you have 4 items. The first item is xe to the x or xa to the x is going to be the same as in example 8 here, and it's going to be x sine x, x cosine x. That's going to be the second item. The third item turned out to be the log 1, that you have u always equal to log x. And the arc trigonometric one is going to be u equal to arc trig x. Okay, and sometimes if you reduce the term into this one, it's still complicated. Okay, so if you reduce something like this and you have something complicated, so the thing that you gonna be able to do is gonna be you're gonna use by part one more time. Okay, so you use by part one more time and you be able to reduce into the thing that manageable. So you'll be able to integrate this term, and you see that the yellow guy is easier to integrate, and this will be helping you in order to find the final answer of the integral or integrate that you're looking for. Okay, I'm gonna continue next time on by part. Okay, so the next time is gonna be by part that kind of tricky, that you have to like move to the other side. So it's gonna be another part for by parts.